Uh, okay, so the types of triangles for the law of sines is, so the cases are where the first case is where you have either an AAS or an ASA triangle, right? So A stands for angle and then S stands for side, right? So if you have a triangle where you know one side and two angles, then we can use the law of sines. And the other situation is for an SSA triangle, right? So side, side, angle. So where you know two sides of the triangle and one of the angles that are not between the two sides. So this second case is a little bit trickier because in the case of an SSA triangle, there's a possibility that you have either one, two, or no solutions, depending on how the calculations turn out. So this situation you want to be careful about.
How could you have more than one solution? Aren't you looking for one thing?
Wait, can you repeat the question again? I didn't get that. Can you
How
repeat
could
the
you
question?
have more than one solution? Aren't you looking for one thing? Looking for a side. How can a side have more than one answers to it?
So the reason is because typically in these problems you have incomplete information, right? And uh, you'll run into a situation where there's two possible triangles that can have the same information. So what do I mean by this? So let's say, so you know two sides and an angle, right? So so say you have uh so a triangle that looks like this. Let me draw a little bit bigger so it's a little bit easier to right. So by SSA for this triangle, what I'm referring to is these two sides and this angle here. Okay, so SSA. Uh, so I can draw this triangle this way, or I can spread the side on the right farther out. So that looks kind of like this. So let's call this S1, S2, and A. So this is S2 and A. I didn't draw this example very well, but in any case, this is essentially the situation where I can draw two different triangles that have the same side lengths, and then angle A is the same, but the top angle and then the other angle is different. And so you can have, so basically the unknown sides can be different in these two triangles. Basically, the reason this happens is if you remember from geometry, there are different situations where you have congruent triangles. So for an ASA triangle, right? So if you have two triangles where you know one side and two angles, then the two triangles have to be congruent. But that's not the case when you have an SSA triangle, right? So if you know two sides and one of the other angles, the two triangles don't necessarily have to be congruent to each other, and that's why there's two solutions.
Professor, is the final exam last for like 1 day full, or like last time?
What do you mean?
I mean, is it is it like in our ordinary time, like 8 to 9, 10 p.m., or it will last for that day?
Well, you can start it within the day, but there will still be a time limit. I mean, you can't just work on the problems all day long.
Got it. Got
Right.
it.
So
Thank you.
like test 3, you could have started it either Friday or Saturday, but still you only had 3 hours to do it, right?
Yes, thank you.
Okay, so these are the situations where when we want to use the law of sines. So so here I've already done this example. Right, so here this is an AAS triangle, right? So as I said before, two angles and one of the sides, right? So you're given that angle A is 34 degrees, angle B is 46 degrees, and then side A here is 12 and a half feet. And then the other side, angle C is unknown, and then sides B and C are unknown. Okay, so we want to figure out the two unknown sides and then the unknown angle. In terms of angle C, that's pretty straightforward to figure out, right? Because for any triangle, again, the rule is that all three angles in a triangle should always add up to 180, right? And because we know both angles A and B, we can calculate angle C by just subtracting, right? So angle C has to be 180 minus 34 minus 46. And so if you calculate this, you get angle C is equal to 100 degrees. Okay, so here angle C is pretty straightforward to calculate. And then now for sides B and C, this is where we use the law of sines, right? So so because side A and angle A is the one where we have complete information on, when we calculate B and C, we want to relate it to side A and angle A, right? So so here I've used the law of sines involving A and B, right? So so this is the formula for A and B, and then I just plug the information in, right? So A is 12 and a half, angle A is 34 degrees, and then angle B is 46 degrees. And then so we just set up the equation, and then now side B is the unknown, right? So to get side B by itself, I need to multiply by sine 46 degrees over to the left side, right? So this is what I've done here, and then the rest is just a calculation, right? So so here we're working in degrees, right? So you should make sure when you do the calculation that you're in degree mode. And then again, this is just now just calculating, right? So it's 12.5 times sine of 46 degrees divided by sine of 34 degrees. And you see, I've rounded it to one decimal place, right? So the 7 makes it round up, right? So you get 16.1. Okay, so here we just use the law of sines to get B, and then to get C, it's similar, right? So so we've previously determined angle C, right? So angle C was 100 degrees, And then now the only thing that's missing is side C, right? So again, we can relate it to side A and angle A because that's the one where we know completely. So why won't this thing scroll? I don't know why this doesn't. Oh, there you go. Okay, so solving for side C is similar, right? So so I relate it to side A and angle A, and then I have a similar equation, and then we just calculate C in this way, right? So 12.5 times sine of 100 divided by sine 34. We can see is about 22. Okay, so so we've solved the missing sides and angle for this triangle. So for an AAS triangle, you can solve it similarly, except it's the first step is a little bit different, right? Because the only way we were able to get C is because we already knew the other two angles. Oh no, this isn't AAS. What's the other? What's the other one? ASA. Where you also know two angles. Okay, so it's pretty much the same in that case.